Alright, so today we're working with rational exponents. We've seen these before actually. So it's just taking a radical expression and writing it as an exponent basically. So quick review. So we've seen this before again, like square root of x, that's the same as x to the 1/2 power. So that root is the denominator in that. Cube root of x, for example, x to the 1/3 power. Now we can take that even further. What if it wasn't just a root, but we had an exponent in here? So in general, okay, and I would encourage you to write this thing down. A to the m over n is the same as the nth root of a to the m. Or you could write this power outside, so the nth root of a all raised to the m power. Again, that's really the big relationship we're using today. So let's just practice going back and forth again. So write the radical or exponential form. So radical form just has the radical and exponential just written as an exponent. So x to the 3/4. Again, here's the power, here's the root, if you want to think that way. So we could write this as the 4th root of x cubed. Or again, I could put the cube outside if I want. Okay, how about something like this? A decimal, 0.666. So repeating. Well, that's 2/3, right? So this is the same as n to the 2/3 power. Now it's the same problem. So that is the cube root, right, on the bottom, that's my root, of n squared. Very similar. Now this one's negative though, so this is the same as m to the negative 1/3, again 0.3 repeating. So negative, remember what negative exponents do? So for example, negative 2x to the negative 2, that means 1 over x squared. So you just flip it and write it as a positive exponent, okay? So same thing here. So this would be, 1 over m to the 1/3, which of course we could write as 1 over the cube root of m is the way we could write that, okay? How about this guy? We're just going the opposite direction now. So m, now notice this is a square root, so that would be the same as m to the 7/2 power. So the power and the root. How about this guy? Very similar. So now I've got two things here. So this would be the same as 4y, I'll just put the whole thing in parentheses there, to the 5/2 power, and it's a square root. Something like this. So we've got 9n to the 7/3 power. Again, power and root. Not too bad. Okay, hopefully you get a good feel for those. Okay, how about some things like this? We're just simplifying. Maybe we've got some numbers. 729 to the 1/3. Well, that means the cube root of 729. Let's just plug in a calculator, like Desmos. Okay, so you could type it in like this as a cube root. So 729, just type it in here on the screen, you can see what I'm doing. Oh, that's 9. Or again, just to illustrate, I've done this before, but you could also just type it in 729, just like you see there, to the 1/3 power. Hey, it's 9. Notice you get the exact same thing, okay? This guy, the second one. In fact, let me just write that real quick. So this is 9. We just simplified that. Now this, you could type that into a calculator as well, but let me show you something. Remember exponent properties? We've got a power raised to a power. You just multiply those. Well, what's 6 times 1/3? Well, that's 6/3 or 2. So this is the same as 3 squared. Hey, that's just 9, right? Quicker to think about it than go plug it in a calculator. I've got another example here. Let's see what we got. Negative 8 to the 2/3. Again, you could just go plug this in, or you could simplify it pretty easily just by breaking it down. What does these things mean? So let me again illustrate that real quick. So this means the cube root of excuse me, cube root of negative 8, and I'll do it this way. I'll go ahead and square that at the end. Well, what's the cube root of negative 8? That's negative 2. You square it, hey, you get 4. Okay, but again, let me just illustrate. Let's plug that in a calculator real quick just to show you. You could always do this, or certainly you could check yourself, right? So if I do 2/3, hey, there's our 4, like I just showed you. Now, how about something like this? Let me minimize that for a sec. Now we have an x in there, so I can't just plug this in a calculator, but I can remember negative exponent, so we could just flip the whole thing. So that means 1 over 8x to the 15th all to the 1/3. Well, let's simplify that a little bit. What is, I'm going to write it down here where I've got a little more room. What's the cube root of 8? That's what that 1/3 means. Cube root of 8, oh, that's 2. What's the cube root of x to the 15th? Or you could do 15 times 1/3, well, that's just 5. So that's x to the 5th. Hey, there's our answer. Not too bad. How about something like this? 9 to the 5/4. Those are exponents, okay? They didn't show up super well, so those are both exponents. 9 to the 5/4 times 9 to the 3/4. Well, remember when you've got the same base there, you can just add the exponents. So 5/4 plus 3/4 is 8/4, that's 2. So that's the same as 9 to the 2nd power. Hey, that's 81. And again, you could just go plug that in a calculator and check yourself as well. Very similar. What if we're dividing here? Same base, 7 and a 7. So you could just subtract these exponents. So this is the same as 7, let's see, 1/2 minus 3/2. So that would be to the negative 2/2, which of course is negative 1. So 7 to the negative 1 equals 1 over 7. Not too bad. Those are the big things you're up against today, just using these properties. It'll have like an interest rate problem you'll probably see. Just look through what they do. It's really just plugging values into a calculator, being careful. Make sure that final answer you get on that interest rate problem, it's going to give you a decimal, then you'll just convert that to a percentage. But pretty straightforward, okay? So have a great lesson. Reach out with any questions.